Well, you guys, welcome back after spring break. I hope everybody had a good, relaxing weekend. We are going to move from exponential functions into logarithmic functions. So I'm just going to read this little paragraph here. It says f of x equals b to the x is an exponential function, as you should now know. Exponential functions are one-to-one functions. This means that f of x passes the horizontal line test. So for example, if I were to have this function, it passes the horizontal line test, right? If it passes the vertical line test, that means that it's a function. If it passes the horizontal line test, that means that its inverse is also a function. So therefore, exponential functions have inverse functions. The inverses are called logarithmic functions. Logarithmic functions are defined for all positive real numbers x and b. b, your base must be greater than 0, and b cannot be equal to 1. So think about this. If b is equal to 1, what's 1 to any power? That's just 1, and that's just going to give you a horizontal line through y equals 1. Okay, so your base has to be positive, and your base cannot be equal to 1. Okay, so let's take a look. Y equals, this is how you read this, the log of x to the base b. That's how you read that thing, the log of x to the base b. So y is equal to the log of x to the base b if and only if, remember that from geometry, b to the y is equal to x. So just take a minute here and look at the pieces parts here. Your base of your logarithm is the base of your exponential. The y at the beginning, so whatever your logarithm is equal to, that's your exponent. And x is the argument or the object of your logarithm. Okay? So that formula shows you how to convert back and forth from a logarithm to an exponent, or an exponential, and from an exponential back to a logarithm. This is going to be super duper important that you are able to convert back and forth between those two types of equations. Okay, and we're going to practice that, so don't worry. Okay, the base is b, and the exponent is y, which means that a logarithm is an exponent. 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 I cannot stress that enough. When you're finding logarithms, you are finding exponents. Okay, so like I said, it's important to be able to write back and forth between exponential and logarithmic functions. We're going to rewrite each of these. If it's a logarithm, we're going to write it as an exponent, or as an exponential, and if it's an exponential, we're going to write it as a logarithm. I'm not going to do all of these with you, but I will do a couple with you. Okay, so let's take number 1. Our base is 7. Our logarithm is 2, so that's our exponent, right? A logarithm is an exponent, and your base to your exponent is always equal to whatever this argument is here. Okay, we don't have to solve these. We're not going to solve these right now. We're just going to practice writing back and forth. Now, obviously, this one's easy. X is equal to 49. How about this one? Our base is 3. Our logarithm is -4, so our exponent is -4, and it is equal to the argument of the logarithm, which is an x. Okay, let's go down to number 5. Our base is b. Okay, our base is b. Our logarithm is 4, so our exponent is 4, and it's equal to our argument, which is 81. And then in Algebra 2, you learned how to solve that. You would just take the 4th root of both sides. How about this one? This one's an exponential. That's interesting. How about we rewrite it as a logarithm? Okay, so our log, what's our base? Well, our base is 3, so that's got to go down there. And I don't know what my argument is. I know that my exponent is a y, so a logarithm is an exponent, so the y goes there. And then that must mean that the 15 is my argument. It's the object of the logarithm. Okay? How about we do number 9? The log of the base, which is 6. Our exponent is 3, so that's what our logarithm is. Sorry about that, you guys. All right, so our base is 6, our exponent is 3, and our argument is x. So I'm going to leave the rest for you to do, and we're going to move on. Okay, so there are three types of logarithms. We have this first kind, which is called a regular log. Its base is b. It could be 2, it could be 3, it could be 72, it could be a half, it could be 2/3. It could be anything as long as it's positive and not equal to 1. Okay, they're called regular logs. So if we had y is equal to the log of 9 to the base 3, that means that 3 to some power has to equal 9. That's pretty easy to solve, but we're going to hold off on solving until later. Notice the difference between the first kind and the second kind. What's missing? Oh, there's no b in there, right? This one has a b up here, and this one doesn't. If you see a logarithm written without a base in there, then it's understood that the base is automatically 10. This is called a common log. Okay, so if you see y equals the log of 0.001, that means that 10, your invisible base there, 10 raised to the y power, is equal to 0.001. Okay, again, we're not going to worry about solving that yet. We'll talk about how to do that later. And then the third kind, well, this one's kind of crazy. This one doesn't have a base, and it doesn't even say log. It says ln. That's how you say that, ln. Okay, not ln, ln of x. This is called the natural log, and its base is e. Okay, so this is the base of this guy is whatever b is. The base of an log is 10, and the base of an ln is e. So if you had y equals the natural log of e to the fourth, that means that e, your imaginary base there, raised to the y, is equal to e to the fourth. And that's pretty easy to solve if you remember last week's lessons. Okay, so there's a change of base formula. Back before you guys had graphing calculators, we had to use this change of base formula, and we had to use tables that were in the back of our textbooks in order to figure out logarithms. So this was the change of base formula. Notice that you can write it as LOGs or as LNs. Okay, so if you have the log of x to the base b, you can do the log of x divided by the log of b. So you're changing from a regular log to two common logs, right? Regular has a given base, common logs base 10. Or you can use natural logs. The log of x to the base b can be the ln of x divided by the ln of b. However, you have these awesome fancy schmancy calculators, and there's actually a log base key on the calculator. So you're going to hit the math button and then scroll down to A, or you can hit alpha A. So I'll show you what that looks like. We're going to do this problem. Okay, I'll show you both ways. So actually, let's use change of base formula first. Change of base formula says that this is equal to the log of 4 divided by the log of 3. Or I can do the ln of 4 divided by the ln of 3. Or I can use the log base button. Okay, so let's do this one first. Now, the power of parentheses, people. All right, so I want the entire, when I hit the log button is right here. Okay, when I hit the log button, it automatically prompts me with a parenthesis. So I want to make sure that I put the entire numerator in parentheses and the entire denominator in parentheses. So I'm going to start with a paren, log of 4. Now I'm going to close the 4, and then I'm going to close my numerator, divided by, and I'm going to start off my denominator with a paren. The log of 3, close the 3, close the denominator. And we get 1.262. 1.262. I can do ln's also. So again, I'm going to numerator and denominator in parentheses. So paren ln, the ln button is right here, just below the log button. 4, close the 4, close the numerator, divided by, start your denominator with a paren, ln 3, close the 3, close the denominator, and you get the same answer, 1.262. All right, now let me show you the fancy schmancy log base button. So you're going to hit the math button, and you can either scroll down until you hit alpha or until you hit A. See that log base there? But you don't have to scroll. You just hit math and then hit the alpha key and then the math button again, because that's where the A is. And it'll automatically give it to you. And then we can just type it in. Our base is 3. And I'm going to use my arrow keys to move over there and type in the 4. And I get 1.262. So 3 different ways to find the same answer. Now I want you to think about this. This log of 4 to the base 3, that means I don't know what that's equal to. Well, I do know now. That means that 3 raised to that answer that I just got is going to give me 4. So I'm going to double check it. I'm going to do 3 raised to that big long answer. Remember, we don't want round off error, right? So 3 raised to the answer that I just got. That should give me a 4. When 3.999999 is pretty dang on close to 4. So here's what I want you to do. I want you to try 14 and 15. You guys have your calculators. I signed them out to you. So go ahead and try those, and then I am going to start a new video.